Hi everyone, this is the 7th session of writing a Lisp in Python. So I'm going to open the environment. In the last session we implemented a battery test, a test battery. So we've got tests to detect regressions in lookup, in the lookup function, simple evaluation, and computing Python native function. In the interpreter, we have the compute function completely written, but not entirely tested, and we don't have the expand. We have to implement the expand macro function, and I think we have the evaluate function written here, but we need to test it. In order to run the test, I can just run pytest, and every test is going to be collected. Each item is a function in this file. So in order to test Lisp function computations with a compute function, we need to define Lisp functions, and to do that we need to implement the function definition function, which is going to be either a macro or a special function with a manually evaluated arguments. In order to simplify implementation, I'm going to skip this type of syntax that can be found in Scheme. I'm not going to define function definition in define. I'm just going to use lambdas. So I need to define, I need to define lambda, and I need to define I need to expose the built-in constants in the environment. I can't use define global because this is used for functions, so I'm going to do it manually. tests, I'm going to try to parse the built-ins.lisp file. I'm going to copy paste this code as an example. I'm going to add a wrapper over this code. No, I just forgot that Lisp has to be evaluated one expression at a time. So if I have multiple definitions in this file, I have to evaluate this before parsing this. In the parsing algorithm, I didn't take this into account when I defined the tokenizer and the source mapping. So I have to source map and tokenize the entire file before evaluating expressions. I think I'm not sure why I had to oh yeah, so the parse expression, the read expression, it requires tokens to be reversed, and this is specific to the parsing function, and I can't make this a part of the tokenizer, otherwise the tokens will always be reversed. So I'm going to keep this reverse call here. Over here I have the tokens, not the correct ones. This is not the correct file. Oh yeah, I know why. This code, which is a manual test, has to be put in a function. I'm going to fix this test first. So I created this directory. It's not a directory. I'm going to use this directory and move all the source code that is used for tests in this folder. And I'm also going to number these files so that I can put the simpler tests first in this list, in this file tree. So this is the test that I need to convert into assertions, from print to assertions. I am just hard coding the results because I already checked manually that this is correct. I verified it in live in the first sessions. So I'm just making sure that I don't have to check it manually and the tests are automated. Okay, so tokens can have a type equal to syntax, string, number, or symbol. The first one is a number. The second one is also a number. Then we have a string, then a symbol, then a syntax parenthesis, then a symbol, string, and syntax. The test is giving an error because there is an assert, a false assertion at the end of the file, but these tests are valid. I just want to check if the number is converted to an integer, and that's not the case. So I have the value here. I'm not going to add tests for the exact positions in the file for the source mapping part. I'm going to add it later. Okay, so I'm not going to write all the tests here. I'm using placeholders, and I'm going to go back to the interpreter tests. going to import the representation function. Okay. So I can parse the value. This is correct. I'm going to hardcode this result. So yeah, I need to define in the built-ins, and I didn't define it. The define function takes two arguments, the variable name, a symbol, and a value, any value that is going to be evaluated. I think I need to access the environment. I'm not sure what I did in the last session. Okay, so I don't send any environment in the native function call, but in the case of define, I need to evaluate manually the expression in the current scope, not in the global environment. So I need to take the environment as a parameter here, the current environment in the parent scope. So I'm going to send this environment if I'm not mistaken, the arguments are always a Lisp list, a const cell. So there is this wrapper that converts the Lisp list into a Python list. And this is where we add the environment. Okay, now every function will require an environment, but the only functions that use this environment are defined, and that's it. All of these functions do not use the environment, so there is still a problem. I don't want to add an environment every time I call a function. I will have to if I keep this environment parameter. I could check. I could write another wrapper. Yeah, I think that's what I will do. So I'm going to write a new wrapper. And this one will add an environment parameter, because special functions tend to require the environment. If you look in the interpreter, the compute function will already use the environment in order to evaluate parameters or arguments, and will also use the environment when evaluating the results if this is a macro, but there is no use for the environment besides the special functions. So I'm going to keep sending in the compute function the environment, but only the special functions will have a use for it, because they have to manually call evaluate with the environment. So this the usual wrapper for global definitions will take an environment and will skip it, and this wrapper will take the environment and send it to the Python function. And since this is for special function, we can define that the execution mode is this. No, the execution mode is no eval. So now I don't have to modify every time I call the represent function, and in the built-ins I can define this new decorator, to define this function. It's been half an hour and I still haven't defined the defined function. So the defined function is very simple. It's not like the lambda function. We just need to take the environment and define the symbol. I'm going to assert the types to make sure to detect runtime errors. Like if I try to define 5, for example, if I try to define this should not work. So I'm going to raise an error, an assertion error. Actually, define does not have to be a special value, a special function. It can be a simple function, and it should be. Lambda has to be a special value, a special function, but define currently doesn't do anything besides. I'm sorry. It has to be a function, a special function, because this is a symbol, or at least a macro, because this is a symbol. No, it can be a macro, because the macro will be executed before at compile time. So it has to be a special function so that this value is defined at runtime after macro expansion, and f is not f does not must not be evaluated before evaluating the define. So this is actually correct. This is a special function, and I also want to. I'm going to add a new test file instead of using this global file. The built-ins.lisp file should be used for built-ins rather than for tests, definition tests. I'm going to start with a simple definition for the first case. This should break the tests. It should have broken this test. If I change the file, it's going to break the test. Okay, so this should fix this should be fixed, yeah. So I had to rewrite the parsing of this file because the code is not the same, and the code is hard-coded. The representation, the result of parsing the code is hard-coded to prevent regressions when I try to change anything in the parser or in the interpreter or in this tests file. So I'm going to try to evaluate the first. First, I need to create an environment. going to use the global environment, and I'm going to evaluate in the global environment the defined expression. Yeah, the evaluate function is in the interpreter. Okay, so now I'm in the compute function, or no, I'm in the evaluate function. Missing one required argument. Oh yeah. This is a bug in the interpreter. I forgot to add the environment parameter to the evaluate function. Define takes 2 arguments, but 3 were given. Yeah, because I forgot to add the environment here. I don't know how this code even compiled in the Python interpreter. Name evaluate is not defined. Okay, I need to import it. I'm not sure this is going to work. Because in the interpreter I import from the built-ins. This is a circular import. So the interpreter requires the global environment in order to run. Does it? Do I actually use the global environment? No, I don't. Do I need to use represent? No, I don't. Do I need to use environment? Yeah, I do. But I can put this in a different file. My computer is freezing. So I need the environment, but that's all I need. And the environment doesn't really, the environment creation doesn't have to be part of the built-ins. So I'm going to put this in the value, I think. Like this. My computer is freezing because I'm hosting a Monero blockchain on I2P and running virtual machines and more things. The CPU usage is high. And the main problem is the disk access because of the Monero blockchain using the disk I/O. Yep. The file is not written yet, so it can't execute. Function is not defined. So now I can import from the interpreter. So what I did here is that every reference from the interpreter to the built-ins are now removed, and I don't know if this is okay, because I plan to eventually use dynamic lookups for the evaluate function and the other functions like compute. Not compute, because compute is would be recursive, would make a recursion loop, but evaluation maybe no, not evaluation. Lookup, no, not lookup. Maybe the lookup function can be, no, it can't. It can be defined in Lisp, because every time I try to use a variable from Lisp to implement the lookup function, I would have a recursion. But the macro expand function can be defined in Lisp, and I would like to do so. And in order to dynamically refer to the expand function, I would have to refer to the global environment, which is not defined here, it's defined here. I'm going to do this, to put the global environment in a position that is not it is independent. Because this will allow me to import the environment from the interpreter, even if the definition of the environment built-ins requires the interpreter to work. Okay, so the evaluation worked. I don't know what happened, so I need to check the results in the test interpreter. And yeah, so Lisp functions should return something, so I'm going to return nil, and the effect of define should be verified by representing the global environment. I think I should wait. So okay, the define function always defines something in the global environment. So I'm going to do this instead. And the value is evaluated in the current environment, so this is correct. The problem I have now is that once this code executes, the global environment will be modified, and this test will share the same global environment that has been imported from here. One thing I could fix is I can't really fix it unless I can just the only thing I can do here is either run all tests in different PyTest instances, which means running the same command again and again, or simply ignore the fact that the global environment has been modified. So I'm going to modify it only once or twice in this test, but not in the next test. And that's fine because I don't need to test the definition, the define function. Okay, so I have this new X binding, so define works properly, and now I would like to use define to define a lambda. So I need to define lambda, what the lambda constructor is. It's also a special function. I'm going to just write the definition here. And we are going to stop here because it's already been 50 minutes. I can remove define from the to-do list, and I need to run the tests. Okay, so first of all, lambda is a Python keyword. This is better. So the three tests that fail are tests in the parser, are parser tests. So I haven't implemented them yet, and this test is what we are writing right now, which is incomplete. So I will have to finish in the next session. And I think that's it. I'm just going to commit what we did in this session.